One of my favorite sayings from Integrals for You is an integral that keeps the doctor away. So, in the name of Jeff Connors, we are going to solve this integral today. So, first of all, we're going to be using u sub. We're going to let u be the square root of x. And then, of course, derivative of u with respect to x is going to be 1 over 2 times the radical of x. And then we see that, 1 over x, 1 over root x is already here. We just need to make it 1/2. In order to make it 1/2 without changing anything else, we need to multiply this by 2. Okay. And before we do that, if u equal to the radical of x, then x is equal to u squared. Okay, now we can replace this x with u squared, and then everything else will just fall into place. 1 minus u squared, and then du. So now we're going to use another substitution called the trig substitution, because the integrand right now is in such a form that without using Trig-Sub, there's really we can't really use any other techniques to solve it, right? U substitution doesn't work. Integration by parts doesn't really seem to work. So we're going to draw a right triangle. And then this actually looks a lot like the Pythagorean theorem, right? In fact, I can rewrite this as the square root of 1 squared minus u squared, which is the formula for a side, right? And then the 1 is the hypotenuse, u is my other side. So we're going to put 1 here. But where do we put the u? You can go here, you can also go here. But if we put the u right here, in order, from theta's perspective, in order to get u over the hypotenuse, we are forced to use cosine, right? So here's the trick that you need to know. So every time you're using Trig-Sub, we want to get u over a by tangent, sine, or secant, because with tangent, sine, and secant, it is very easy for us to use identities, because tan, sine, and secant, they have nice identities. So we're going to put the sides in such a relation where we can get u over a, in this case u over 1, through tangent, sine, or secant. So we have to put u here, and then 1 minus u squared down here. So therefore, sine of theta equal to u over 1, or u, du will be cosine theta d theta. So you see, we're using substitution again. At first we use u substitution, so now we're using Trig-Sub. So now I can replace my u squared with sine squared. 1 minus sine squared theta. Du will be replaced by cosine theta d theta. So when you're integrating in terms of a specific variable, your differentials must also be the same variable. Okay. Well, this is a very nice identity, because sine squared plus cosine squared is 1. So 1 minus sine squared will give us cosine squared. So 2 over 2 times the integral of the square root of cosine squared, and then the squared is going to cancel with the square root, so leaving us with just cosine theta times cosine d theta, and then that is just 2 times the integral of cosine squared theta d theta. This integral is not really trivial, because integration by parts is going to make it a lot more complicated than it needs to be. U substitution doesn't really work. So what we're going to do is we're actually just going to recall the formula for cosine double angle. We're going to recall cosine 2 theta identities. So one of the identities states that cosine 2 theta equals 2 cosine squared theta minus 1. Why are we using this identity? Because only this identity, it contains a cosine squared. And that is exactly what we have here. So we're going to try to get cosine squared by itself and see what that equal to. So we can replace cosine squared with whatever this gives us, because we don't want to integrate cosine squared. So I can move the 1 over and then divide the whole thing by 2. So this becomes cosine 2 theta plus 1 all over 2 is equal to cosine squared theta. Okay, now I can replace my cosine squared theta with cosine 2 theta over 2 plus 1 over 2. So now I'm breaking my fractions. After I broke my fractions, I'm going to break my integrals. And it is so important that you keep your constants along with your integrals. D theta plus 2 times integral of 1/2 d theta. Okay, very nice. So we can factor out the 1/2, right, with the 2, so that will just give us 1. So now this integral is just going to be cosine 2 theta d theta plus, and of course, this is 1/2 times 1. And then after we brought 1/2 to the front, this is just the integral of 1. But since we're integrating with respect to theta, this will just give us a theta, and then plus c. Now we just need to solve cosine 2 theta. I'm going to let a different variable be 2 theta. I'm going to let t equal to cosine 2 theta. So dt is going to be 2. I need to add a 2 somewhere in this integral without changing anything. I need to multiply the whole thing by 1/2. So this integral now becomes 1/2 times integral of cosine t. So now that becomes 1/2 sine of t. But t is 2 theta, so I'm going to plug 2 theta back for t. Plus theta plus c. We're not quite done, because everything right now is in terms of theta. What we actually want is we want to get everything back to x. So first, we need to solve everything in terms of theta. We are going to solve for u. We're going to plug theta back for u, and then we're going to plug x back for u. So 1/2 sine 2 theta is 2 times 1/2 sine theta cosine theta. That's the double angle identity for sine. Plus, what is theta? If we know that sine theta equals u, then theta must equal to the arcsine of u. So theta is arcsine of u plus c. And this is what's so nice about Trig-Sub, because once after you have the triangle set up, you can just get all of the information from the triangle. So if we want to solve for u, sine theta is just u over 1, right? So sine theta is just u. I can replace that with u, and then by the way, 2 times 1/2, that's gone. So very nice. How about cosine theta? Cosine is the adjacent over hypotenuse, so it's just the square root of 1 minus u squared. So I'm going to multiply that by 1 minus u squared, and then plus arcsine of u plus c. Okay, very good. And then at the very beginning, we set that u equal to the square root of x. So now it's time to plug that back for every u. So u is the square root of x times the square root of 1 minus u squared is therefore x plus arcsine of the square root of x plus c. And then to make this look a bit nicer, I'm going to multiply the two radicals. So now it's going to become x minus x squared plus arcsine of radical x plus c. And that is our answer.